So yeah, walk me through that process of like, senior year of high school, you're choosing a school, you work so hard,
Yeah.
and then you decide on Berkeley.
Yeah. Yeah. Wow. I'll have to like really remember like what exactly went through my head. But I actually had like I was really thinking a lot about where I wanted to go, and or like after I had gotten in and stuff. Berkeley was actually the first school that I got accepted to, and like the reason that I mentioned that is because like I like when Berkeley like accepted me, like I didn't put too much thought into what particular college I'd like to go to. I kind of just applied to various schools and was like, oh, let me just see where I get in, and then I'll see where I'd want to go.
Yeah, shotgun approach kind of.
Yeah. But yeah, when I got into Berkeley, I just started looking up Berkeley more, just reading more about Berkeley. I already knew they had a really good engineering program, but I was just reading more about it, and it just seemed like such a vibrant place with just a really cool vibe, great food, so much to do, SF nearby.
Yeah.
It seemed like it was the perfect distance away from home, where it's like it's just a 1 hour flight.
Yeah.
Or like 6 hour drive. So like I was like, okay, this will be cool. Like it'll kind of feel like kind of like my first time with like independence, but I won't be that far that if there's like an emergency or something, I'm like just stuck all by myself.
So true. Yeah.
So I was sort of thinking about that.
How did going there like make you evolve? Because it sounds like that was your first time living alone.
Yeah. It really actually changed me in so many ways.
Really?
And I'm really, really grateful to Berkeley. Like I think yeah, like one thing I think Berkeley, I think sometimes like has this reputation of being a very competitive, cutthroat place. Sometimes, at least I hear that.
I've heard that in the pre-med space specifically. Yeah. Not as much in like other spaces, but specifically in pre-med. Yeah.
Maybe that's why I didn't experience it so much, because I found that everyone in Berkeley was really cool and just really nice. I feel like I made really, really great friends there. But yeah, like with regard to how it changed me, I think it changed me in so many ways because at Berkeley, so actually like my first semester at Berkeley, I actually really struggled. I was only taking 16 units, which like I thought was about average or something. It didn't seem like I only felt like I was taking a few classes, but I was really struggling through them. And I ended the semester with like a B in math and like a B in chemistry. And it was so upsetting to me because like I'd never gotten a B in math before, or really a B at all. And so it just started making me, the first semester, I think I kind of felt like a little bit like a failure. And I felt like, wow, I don't know if I can really compete here. Like I thought everybody here is so smart, and like, what am I doing? And and I didn't even want to check my grades. Like when my transcript came out at the end of the semester, like I didn't even want to look at it.
Yeah, like kind of like
I didn't want to see. Yeah, I didn't want to see my GPA.
Yeah.
But over winter break, it just sort of like it was like a nice month or so just away from school, and I think it made me reflect, and I realized that actually like part of the reason I was struggling so much is because the pace just moves a lot faster than it did in high school. And I made the mistake of kind of falling behind, because when you live in the dorm, or when I lived in the dorms, people would always be coming by like, hey, do you want to come to the dining hall with me? Like, hey, do you want to come here with me? And I didn't know these people that well, but I'd always say, oh yeah, sure, I'll go to the dining hall. And then 2 hours go by here, 3 hours go by there. And so I realized over winter break that if I just stayed on top of my stuff, this wouldn't be an issue.
Yeah.
And I also realized something important, which was that like all these other people, I made a couple good friends, but like a lot of these other people who I didn't actually know that well, it's like they can't raise my GPA, only I can.
Facts.
So like I'm gonna do whatever I have to do,
a little bit,
cut all that extraneous time out and just focus on trying to do. So then
those people that you went to like dining hall with, did you still talk to like a lot of them? Or it sounds like
no. So, really only my roommate and one other friend from freshman year. But yeah, then second semester I like really buckled down and focused on my classes. And like my GPA up from there. Like I did well in all my classes and stuff. And then I like took on like progressively higher and higher workloads, and I actually found it to be easier and easier over time.
Yeah, you get better at school.
You just get better at it. Like you just like get in the groove of knowing how to do things. Also, I think
you build your self-efficacy too. Like you build your like, yourself.
And knowledge kind of compounds. Like you front load the work, and if you know the base level stuff well, it's a lot easier to do the upper divs and stuff. Like if you've just learned it properly.
For sure. And I think that's interesting. I feel like a lot of times going 0 to 1, that takes a lot of effort. But like going from 1 to 100 isn't as hard. So I feel like those beginner level classes actually, even though they're like beginner level, they're actually some of the hardest ones, because you have to wrap your mind around this new way of thinking, right?
Yeah, a lot of the stuff you're being exposed to for the first time. At least the upper div stuff, it kind of touches on stuff you've already learned. And then you start to be able to draw connections between things, and it doesn't feel like memorization anymore.
Oh, I still love that feeling.
Which I love that feeling.
Then you don't even have to memorize it.
You don't even have to memorize it, and you remember it.
You can just like derive it like kind of from your memory based on what you understand.
And you can actually do something with it, which to me is probably the best feeling ever. To know that like after spending hours and hours and hours on a class, it's not just going to collect dust at the back of your mind, but you can actually do something meaningful with it, like a project, or you can use it to help somebody, or like, but yeah, Berkeley taught me a lot. Berkeley is like, my experience with Berkeley is like, nothing is really given to you on a silver platter. Like you kind of have to go out and seek all the opportunities that you want. And you kind of have to get used to the idea of failing. You have to get really used to it. Because it's like, there's just so many students, and it definitely can be competitive. Although it's sort of just the competitiveness is just there because of the limitations in resources and stuff. It's not because of the people who are very nice. But in my experience, people were super nice.
Maybe that's you projecting a little bit too. You're just a nice person, and just like, I just assume other people are nice.
Thanks. I mean, I only had like one or two experiences where I actually asked other students for help and they said no, but most people were happy to help.
Yeah, it happens.
Yeah, it happens. They're kind of everywhere. Like, or yeah, there's no way you'll find like 100% of people who are willing to help. But yeah, no, I think it was a really valuable experience because it made me okay with the idea of failing, or like it made me not care if I failed. So like even now, like I just apply to things and throw my hat in the ring, and it like I don't hang all my hopes on like, oh, this is going to succeed. Just like, oh, you know what? If it doesn't succeed, I'll go for something else. Or oh, like there's another opportunity around the corner. Like this isn't the end of the world. So
do you feel like you learned from your failures a lot? What's a failure that you've learned like a lot from? Or that like kind of tested your resolve and changed, or made you, I don't know, helped you like develop psychologically or spiritually and emotionally?
Yeah, that's honestly a really tough question, because there have been a lot of things that haven't gone the way I've wanted them to go. But for a long time, I've just gotten so used to just brushing them off and not letting them bother me.
Yeah.
I think one thing that I've learned just from like the sheer number of failures, there was actually, well, I don't know, I'm kind of going on a little bit of a tangent, but there's actually a little cartoon that the grad student lab that I used to work in had, where it was like, it said something, oh, there's no such thing as winners and losers. There's only losers and super losers. And the super losers are the people who've had even more losses than the so-called losers. But on the outside, they look like winners. But in reality, their failures far outnumber their successes. It's just that people look at them and only see their great successes. And so, like, one thing I've learned from failures is just to stop don't even bother counting them. Like, that every time you fail at something, you're just getting better. Every time you write an application and it doesn't get accepted, you can still use that beautifully written paragraph to apply for something else. And now you don't have to do any work applying for something else. And chances are you're likely to get something you apply for.
Yeah.
Like one thing that I like try to tell people who are coming into Berkeley, or whoever who asks me, is like if you apply to like 100 things, just probabilistically, you're going to get some pretty amazing things. And then you come out, like, I mean, other people from the outside might look at it and be like, wow, like that's so amazing. You must be a genius. You must like get everything you apply for. But no, it's just that you keep trying. And it's just that you don't like, and another thing is like, I kind of also learned to not take failures personally, because a lot of times maybe it's because the person who got accepted was like the director's granddaughter, or maybe they were looking for somebody very specific. And it's not necessarily because you yourself are not qualified. You might be perfectly qualified. And so I think I've also sort of learned to see failures not really as a reflection of my lack of ability, but that it could very well also be just because of the circumstances, and that you never know. So don't burden yourself with thinking it's a lack of your ability. Although if there is something that you see in yourself that you can improve on, certainly improve on it. But don't just beat yourself up because you got a rejection, because it might not even be your fault. So yeah.
That's an interesting perspective on it. I've never heard that before. I like that.
What are your perspectives on these things?
I think on failure, yeah, you're right. I think success is an iterative process.
Yeah.
Like we kind of talked about iterations kind of off air, and how it's important in terms of like prototyping and engineering. But I think it's super important in just like life and like kind of improving. And I think like when you were describing how like probabilistically you can just apply to a bunch of stuff, and like those things, those super failures who are the people who, you know, fail more than like the average people. And then there's like, they have some great successes as well. And those are the things that stand out. I think it's interesting because a lot of the like different like investment, like VC funds, and like different like people who invest in startups and businesses, and even like record companies who invest in artists, like oftentimes like they might have a Drake and they might have a Celine Dion and they might have a Beyonce.
Yeah.
And those are like the big win. And then the rest of their catalog is a bunch of no-name people who are like making them lose money.
Yeah.
And so those are kind of their failures. But those a few unicorns, it's like the Ubers they have, it's the, you know, Airbnbs that they have, even though they have a bunch of other companies that maybe run of the mill, maybe even kind of negative and don't even work out in the end. But it's those great successes that you see. And so I think that just trying different things and kind of being okay with like living with the results is kind of that's how you have to kind of go at things.
Yeah, like I think these investors and stuff, like they know that if they invest in like 1,000 companies, only one of them is going to succeed. And so they know perfectly well, like, oh, there's no way these are all going to, like, most of them are going to fail, but maybe one of them is going to succeed. And then that makes up for all the failures. And yeah, actually one thing that I've wanted to do, because I think sometimes people look at other people who have succeeded and they just think, oh, it's like this person must have always succeeded. And, you know, like, I don't know, sometimes I think like we see really successful people and we're like, wow, they're so successful. And here I am failing left and right. Like, so one thing that I've actually got this idea from a friend in college. But one thing I wanted to do is make a failure CV. So normally, like,
yeah, because your failures can be like actually even super impressive too.
And like it'll be a much longer CV than the CV of successes.
Yeah, so true.
But I just thought it'd be like a nice thing to do, to because whenever people, like, I don't know, sometimes younger people or people who are applying to medical school will be like, oh, can you send me your CV? And I've always thought, oh, it'd be nice to not only be able to send them like my regular CV, but also send them the failure CV, and kind of as a way of saying, like, it's normal to fail, and the more you fail, like, the more you will ultimately succeed if you just keep trying. So, yeah, and if you don't let failure bother you.
Yeah. So that kind of touches on your experience at Berkeley. Then you go straight through and you decide to go to medical school at USC. Tell me about that. Tell me how you ended up here of all places.
Yeah.
Like, was USC on your radar the whole time through, like, when you were applying?
Yeah. So I actually worked at USC during my gap year.
Oh, really?
So I had one gap year between when I graduated from Berkeley and when I started med school. And so in that gap year, I worked at a really small bioengineering organization on USC's main campus.
Oh, shoot.
And it was basically what they essentially did, or like their whole mission, I guess, is to essentially develop new projects or ideas and then patent them, and then either license those patents out to other companies or spin out their own companies. So it was very fast paced.
That's actually really cool.
It kind of a startup. It was a really, really small organization, and you're wearing multiple hats. And I loved it because I got to start my own project and do everything for it.
That's really cool.
And I learned so much. And you were asking me where I learned the most about how to do practical engineering. It was actually all the projects, more so than any of the classes. Like the classes, like, it
was like those projects that you did during that gap year specifically,
and before, like projects at Berkeley too, because a lot of my classes at Berkeley had projects associated with them, but it was really the projects where I would learn a lot, because you're failing, and then you have to, a lot of times you're like looking stuff up on the internet, like, this didn't work, how do I do this? And then you just learn by doing, and then everything you learn is practical and directly applicable, so you remember it better, as opposed to a lot of theoretical stuff. But yeah, like during my gap year, I worked on a project that was basically use machine learning to look at different images of medications and then automatically classify the medications.
Oh, you told me about this before.
I think I probably mentioned it before, but yeah, that was what I worked on. It was really, really fun, and I learned so much from working on that project. So that was what got, although I already had USC on my radar before that. But I think as I was looking into different medical schools, and just doing my research on all of them, I did think it was really cool that USC sort of has this culture of, well, a lot of things, but one of them is technological innovation. And I saw that more at USC than at a lot of other medical schools.
Oh, wow.
That was something that I was interested in, because I do want to continue using what I learned in engineering.
Yeah. I thought that was interesting. We've talked so much about like projects and how projects have the power to like kind of change, like develop your education. Can you tell me about some of the projects that you're doing now?
Yeah, like a lot of them some of them are more early ideas.
Okay.
Yeah. Some of them are kind of hot. Some of them aren't super techy either.
Yeah.
Some of them are just very random things.
They're kind of cool though.
But like, one really random thing this is actually probably what I'm just going to try to knock out in the next month or so. Like last year, I think I told you I like photographed all the flowers on campus. Me about this, So I'm trying to put together a coffee table book for that.
That'd be so cool.
And then, I don't know. I want to see, I've kind of heard that could be possible to actually get it published through USC. So I kind of want to see if that's possible. I didn't initially know that would be possible, but that'd be cool.
I think that'd be pretty cool.
So that's something that I think I would like to just knock out, especially since I've already taken all the pictures.
So you're like, because you're like halfway done. It's open loop, so you just close it.
Yeah. I don't like having open loops. I feel like I need to close them.
I kind of like having like leaving things open because it like I have a strong motivation to get back to it.
Yeah.
It's like you want to close it. You want to just finish it.
I feel like I'm also so motivated to close it because I feel like I have way too many ideas for things I want to work on. But if I have too many open loops, I feel like I should just close the loops before I start the new one. So once I close the loop, then I'm like, all right, yes, I can start something new.
So it's kind of like you're excited that you finish it, but you're also like, thank God, now I can move on to this thing like I've been dreaming about.
I feel like that's literally me constantly. Sometimes I'm just excited to like get projects done, even though like I'm like genuinely excited about all the projects. But I feel like because of how limited time is, I'm just like, I just want to get that done, and I want to get this thing done, and I want to get this thing done, and just like get it off my plate forever, and just like have it done and have it sit on my shelf and never have to think about it.
Now it's like a trophy. You can just be
now
like,
it's like a little trophy.
How do you like? I've been wanting to ask you this because for me, I'm kind of still figuring out like how to organize my different projects, and like I've come to a system that I'm kind of fond of, but I'm kind of curious to know how do you kind of work with having like kind of multiple projects, kind of sounds like open and making progress on different fronts. Like how do you like go about like doing that, and then obviously balancing that with like your medical school, like it's kind of a lot.
Well, I think for me, honestly, the thing that I'm most in danger of is, or the thing that I would never want is to just forget about something. Because I think sometimes, not that I have a lot of projects currently.
Forget about something like a project or an idea? Or
both. Yeah.
Okay. Yeah.
So
that's scary.
Well, if I've already started a project, then I won't forget about it.
Yeah.
But sometimes an idea will cross my mind, like, oh, this would be such a cool idea for a project. Or wow, why the heck is this system like this? I'm sure we could come up with something better. And I'll think in my head, like, wow, I really want to work on this project, but if only I had more time. So then I'll write down the idea somewhere. And so I just keep a gigantic list of, like just a gigantic list of project ideas. And I like have the list categorized. And so it could be like, okay, like medical technology stuff, like these are all my ideas, or stuff related to writing, here are my ideas, stuff related to space medicine, here are my ideas, stuff related, even like, so it's multiple to-do lists almost, except the project related ones aren't always as time sensitive in exam. So like I have my like med school to-do list, which is like, okay, I have to like get that done by next week. The
things that are urgent but not necessarily important,
but I just don't want to forget about them. But like the other things though, I just don't want to forget. So I just make sure they're always on the list, because then whenever I look at it, it just goes to the back of my mind. Like, okay, I'm going to try to make time for this today, or I want to push this forward a little bit today. Because otherwise I think I can get very consumed whatever I'm currently doing. So like if I'm studying, I'll be like, oh, I should just study all day. Like, oh my God, I have so much to study.
I feel that,
But then once I look at like, even just looking at the list of projects or things I've always wanted to do, I just think, wow, like if I could end the day being like, I not only studied, but I like chipped away at that, it'll be that makes me proud of what I did that day.
Yes.
So
it's so funny too, because I feel like I've had this experience where if I was to study every day, I'm not sure if this is the case for you, but sometimes I feel like if I was to study every day, like, and do a good job of like having productive study, that would make me kind of excited and maybe a feeling of accomplishment. But if I was studying and then like half of that time devoted to actual projects and maybe actually finishing those projects, that feeling to me is just like, it's just a whole nother sense of accomplishment. I
feel this exact same way. Like there's only so much gratification I get from just studying.
It sounds like you're more of an application-based change, but I actually wanted to ask you, like, what do you love about medicine? Like, because I know you kind of changed like paths a little bit when you came from engineering to like the medicine pre-med track, and obviously now you're here. What do you love about this that we're in?
Well, what I love about it is like one thing I had kind of like thought, like been telling you a little bit earlier, was just that I really do love learning things. Like I just find it so cool, especially when there's a lot we don't know. I think that's just the most exciting thing. That there's just so much left to figure out. Also, the human body is so complex. I sometimes think it's just basically a biological machine with all these moving parts and tubes and connections. And like it's just like a machine. And I think it's so cool. Like it's so cool that somehow we were just born this way, and everything just works. I don't know. It's crazy to me.
That is pretty cool.
There's so much that can go wrong, and we're here and we're functioning and we're thinking, and I don't know. I just think the human body is absolutely amazing, and so I really, really love all of the science in it. And but I also think that another really nice component of medicine is that you also get to heal people, not just with your knowledge and stuff, but also just by caring about people genuinely, and asking how they're doing, giving them the time of day, and really, really treating people like they're your friends, or treating people like they're your family members. I think that was actually one of the things that made me really drawn to the medical field, because when I started volunteering at the Alzheimer's Center, like I walked the first day I was volunteering, I walked through the door and there was this one Alzheimer's patient who sat right by the door. And she just looked at me and she said, "Thank you so much for being here. You could be out there doing all those young people things, but instead you're here with the seniors. And I just really want to thank you." And it was just such a rewarding feeling knowing that you can make an impact on people with your time, because I think in our society, I think we're sort of conditioned to or trained to be rewarded for our accomplishments or our achievements and taught that those things really matter. But this was, I think, a very nice reminder that we can really make a great impact and really be appreciated by, not because you created something or because you got straight A's, but just because you took the time out of your day to be there with someone and to show them some genuine care and compassion. And I just thought, wow, if I can make an impact on people every day just by being nice to them, that's such a nice feeling to know that not just what you do matters, but who you are matters and what you value matters.
So facts.
And with regard to engineering, actually kind of tied in as well, because with all the engineering classes, you learn a lot of tools to solve problems, which is really, really valuable and really awesome. But you're not actually in the hospital. So you don't see what problems need to be solved. And I started finding by talking to the Alzheimer's patients or by talking to other students at UC Berkeley, that actually informed a lot of the engineering projects I did, because I heard about flaws in the system or just problems people were having that needed to be solved. And then I kind of knew, like, okay, now I know what to work on and I know how to do it. So now I can do it. And I realized that knowing what to do in the first place, you really learn that by talking, or both by talking to people often who are experiencing things, or just by being observant, keeping your eyes open in the hospital. What's inefficient? Like, why is it done that way? Don't you think we could do this better? And just by the combination of those two things, then you know what problems to solve, and now you have the tools to solve them, and then you can do something about it. So that was kind of another reason for why I was like, I think I want to go into this field, because not only would it be gratifying, but it would actually make me a better engineer too.
And kind of like leveraging that like engineering skill set for like problems in like this space, which is like the healthcare / medicine / wellness.
And I think that's like, I mean, I don't know where the future is going to go. Like, I don't even know what I'm going to do tomorrow. But
so do you know like, because obviously I know you've done your Star Talk stuff. Like, do you know if like what is like an ideal career look like for you? Like, I don't know, 10 years down the road from now, do you know like if you want to be like almost like a physician, kind of like problem solver, maybe entrepreneur, or is it more like, I don't know, obviously, you know, you're interested in like astromedicine and stuff like that, so maybe like a physician astronaut, or like, I don't know, what is the future like hold for you?
Yeah, that's a really good question. I don't really know. But ever since I kind of found out about the field of aerospace medicine, it's been more exciting to me than anything else. And I've never been able to get it off my mind since. It's just something I'm so passionate about. So I think that is my, well, I think it was like, I'd say like March of 2020. Because that was my senior year, or it was in my senior year at Berkeley, and they were doing a TEDx event. So they were just inviting speakers and stuff. And then afterwards, you can go and actually like meet the speakers and talk to them. And so one of the speakers was a Navy, like a flight surgeon for the Navy.
Oh, wow.
And so I wanted to talk to her afterwards. So I talked to her for a little bit, and I was just asking her, like, what's that like, being a doctor for the Navy? And she was just telling me that one of the things she loves about it is you get to see all kinds of things that you would never see normally on the ground, things that just really come up if you're at really high altitudes or moving at really high speeds. And she just gets to see all these unique things that doctors on the ground would never really encounter, or patients on the ground never really experience. And so then that got me wondering, and I just asked her, is there such thing as a doctor for astronauts too then? Like, if there's a special doctor for like the Navy, like would NASA have their own doctors? And she was like, yeah, it's actually a field called aerospace medicine. And she's like, that's actually a real thing. And I went home that day and I looked it up, and I like haven't been able to get my mind off of it since.
Wow. That's pretty cool. That's a hell of a story. So that's how you got started in it, and now you're giving talks in it. So,
well, it came with a lot of help. So like, I didn't really know anyone in the field. So I started basically like cold emailing people or just reaching out however I could. And there were people in the field who were nice enough to actually respond to me and get back to me, which amazed me, because I just thought, okay, there's no way they'd have time. Also, I had done nothing to prove myself in this field. I was just some kid who was interested in it. So like, I had no qualifications under my belt, and these people are super busy and accomplished. And all I had to say was, oh, I'm about to start I'm going to start medical school next year, and I'm just really interested in this. And do you think you could tell me how you got to where you are in your career? And there were very, like, a couple people were really nice and wrote me back nice, like really long messages all about how they got to where they were. So that was one of the first things that made me be like, okay, I think I have a much better idea now. If I actually wanted to do this, how to get there? Because I didn't even know if it'd be possible to just go to any medical school and then do that. Or I thought maybe you'd have to go through the military first and then go to NASA or something. And that actually is one route. But you can also go to just any medical school. But I didn't really know that until I'd asked. And it's such a niche field that it's really, really hard to, it's just really really nebulous. If you try Googling aerospace medicine or like how to become an aerospace physician, it's really hard. Like it's like I could not figure it out from my Google searches. You just get these like little bits of like what aerospace physicians do, but not how they got to where they are. So or like what advice they'd have or like anything like that. So it was really just I think the thing that was really nice about my whole experience with this is that like the field is relatively small, but the people, like there have been like multiple people in that field who've been so willing to help me when I knew nothing. And now I know more and I can like try to help other people, but it's only because there were people who helped me. So yeah.
Wow, that's amazing. I love that. So what did you learn from like doing those messaging like people in the field?
Oh,
like, how did they get to where they were? Like would they impart to you?
Well, yeah, like they mainly were, or the NASA flight surgeon that I reached out to was mainly telling me that you can he was just telling me all about the military route and then all about the route where you could just go through any medical school, which was what I was leaning towards, given that I thought it was too early to be like, this is what I want to do with the rest of my life. I just thought it was super cool. But yeah, he also told me about different opportunities that I could get involved in towards the end of medical school. So they're not really available right now. But I
feel like what you've done so far seems like a really good start. I mean, you started the Astro, what is the SIG called that you started?
It's the Aerospace Medicine Interest Group. So it's just like a SIG, but for aerospace medicine.
Yeah. And you gave a talk for them too, right?
Yeah.
Can you tell me more about like how the talk went and like kind of like a general contour of like the talk?
Oh yeah, for sure. It was a super fun talk to give because it was basically just all about what space does to the body. I gave a similar talk back in May. With this talk in September, I kind of focused a little bit more, or I also added in a little section on what would happen if we just went into space right now without a spacesuit or anything. What does space naturally do to the body? And like I guess not too surprising, like you would die, but I think the way that you die is actually pretty interesting. Like a lot of interesting things happen, and it makes a lot of sense from a physics standpoint, which I think is also just a side note. I think it's also something that's so cool because I don't know, I just love it when things makes like intuitive sense rather than feeling like, oh, like let me just memorize it because this and this. And if you hold your breath in space, your lungs actually burst, they actually will pop, and that's because you have air in your lungs at a certain air pressure. Space is a vacuum, so there's just no air in it at all. So if you have like air in a closed space, like if you think of a closed balloon full of air and you throw it into a vacuum, it would just pop because the air wants to expand. And it like there's nothing in the vacuum, so
there's no pressure.
There's no air pressure in the vacuum because there's just no air at all. So the driving force for gas contained in the driving force for that gas to expand is insanely massive. So that's why your lungs just because the air just has to get out. So
you have to breathe out all the air.
You have to breathe out all the
air. And with equilibrium, it sounds like.
Yeah, so you breathe out, you like let out all the air, like leave your lungs, and then but now you're left with no oxygen in your lungs. And then another thing that's also happening when you're in space is essentially I think like the best way to explain this is like a couple ways actually. So like let's say the soda can. Like the soda is like carbonated and stuff, but when you open the can, all the bubbles start to come out of it. Like the liquid starts essentially bubbling. That's because the gas used to be dissolved in the liquid. The air inside the can is at a higher pressure. When you release that air pressure, now the gas that was dissolved in the liquid can come out. So that happens to your bodies. We have a lot of gas dissolved in our blood, and that can start bubbling out by the exact same mechanism. The surrounding air pressure is gone, just like with the can let out the high air pressure. In this case, you take away the air pressure entirely. So gas goes from being in the dissolved state in the liquid, like actually coming out in gaseous state. But another thing that happens is something called ebullition, which is basically where the water in your body starts turning to water vapor. And the reason for that is like pretty much the same mechanism. Like if you have a pot of water, you're boiling a pot of water, just like normally at your house. If you let's say you're taking the same pot of water, you're boiling on top of like Mount Everest, it would actually be a lot faster to boil that water because you have lower air pressure. So the gas, like the water is more easily able to get into the gas phase. So when you're in space where you have no air pressure at all, the water just spontaneously starts going into the gas phase. So you go from water to water vapor.
So it's boiling?
Yeah,
or is it just like
the water is turning to water vapor. So the water
so it's just wow.
So like your skin,
so
but you still like your skin is still like it's not gonna burst. Like your skin is like pretty thick
and watertight too, right? So
instead you kind of just pop up because you're like it's like you're kind of
like put it like it's not in your blood anymore. Now it's just
you also have water like in the interstitial space too, like in your like not just in the blood vessels. Like that water is also going to water vapor.
So it goes into water vapor, but it can't really escape your body very easily, right?
Yeah, like you can't. Yeah. And then like the bubbles that form in your vessels can actually like block the flow. Like they can essentially embolize and block blood flow.
Wow.
So that's super painful.
So you get like ischemia too.
Exactly. And then another thing is like any mucous membranes that are exposed will also spontaneously essentially boil or like bubble away because of the water.
So you lose just the water from your eyes and your mouth.
Yeah. So that all happens. But the thing that actually kills you in space though is the fact that you don't have any oxygen, which is actually like kind of a blessing in some ways because like all of that like boiling, like that's all super painful. Like so, but you actually lose consciousness in 15 seconds.
Really?
And then it's actually the reason for that is pretty interesting. When I first learned that, I thought that seems like a really short time frame because that's when you go unconscious.
Exactly.
So I wondered like when I initially read about that, why is it only 15 seconds? That seems a little bit crazy. The reason is that well, not only have you lost all the air from your lungs, and of course the fact that also the gas that was like dissolved in your blood and stuff is kind of coming out of the gas phase. You're losing a little bit of supply that way. But there's actually another interesting reason, and this is like the biggest reason why you go unconscious so fast. Your lungs. So let's say like you breathe out the air, which is good. So your lungs have not burst. your lungs, you can kind of think of your lungs now as like an extension of the vacuum. Your lungs are not filled with any air anymore. So normally when we breathe in air, the oxygen in our lungs that we just breathed in is driven to go into our blood, and then the carbon comes out and stuff, so like just by the diffusion. But if there's nothing in your lungs, then the oxygen that's flowing past the blood that's flowing past your lungs, the oxygen is actually going to be pulled out through your lungs because your lungs have nothing. So normally, like deoxygenated blood goes to the lungs, but the lungs are receiving a fresh supply of oxygen. So the oxygen still has a tendency to diffuse into your blood. But if the lungs have no oxygen, and if it's just a vacuum, then whatever oxygen is in your blood, which already is a limited supply, is getting pulled out through your lungs and going out into the vacuum of space. So you're just losing oxygen incredibly fast. That's why you go unconscious so much faster.
Really? So you just lose all your oxygen, and that makes sense too, because then I guess like deoxygenated blood to your brain does not like, I think that puts you out too. Like if you don't get enough oxygen to your brain, that's like instant syncope, right, or something like that. So I think that's really interesting. Cool.
And then you go into total organ failure within like a minute and a half to 2 minutes. So you will die. 2 minutes into space, you will be dead.
And is that like the lack of oxygen, the lack of blood flow? Sounds like
yeah, well, what kills you is lack of oxygen. It's really like the total organ failure just kills you. The other thing would be painful, like the boiling and all that would be painful. But like the lack of oxygen is the first thing that will kill you. And you'd be dead before.
And you said 2 minutes.
Max.
I wonder what would happen if you had them out there for like a minute and then you just bring back into like the space station, and like what it would take to like recover someone from like critical condition.
Yeah.
Like would just returning them back to like kind of normal pressures, like would do like everything for them and like just be supportive from like what would it take to get them back to be a functioning human being, and like what deficits would they have? That's pretty cool.
That is such a good question. I actually don't know exactly. I don't know. It would be really tough. I think, yeah, if the person's not, I don't know. I mean, I imagine they'd have a lot of probably irreparable damage to their organs and stuff. So I don't know if it would be possible to fully recover somebody.
Yeah, because how long does ischemia take to kill you? I mean, you're saying it kills you in 2 minutes though. So
what happens to the body without a spacesuit? Some of it is actually theoretical. Some of it is just because of like studies that have been done on animals and like basically exposing them to like a near vacuum.
Really?
What is that? Yeah. And these are like the embolism study, like the boiling. Like those studies were actually done quite a while ago. I can't remember like the exact year, but I believe it was at least like 30 years ago. These like studies were done. I believe longer ago, but I'm trying to give a more conservative estimate, so I don't say anything wrong because I can't remember the exact date of the study. But yeah, it's really interesting about what space does to the body without a spacesuit. That's also why I don't really know how easily it would be to bring somebody back if they were exposed for a little bit of time.
Yeah, we've just never done the experiment.
Yeah, like there's just so many unknowns, which is also, in my opinion, just one of the most exciting things about this whole field. So there's just so much, and we're living in a time where in our lifetime so many more people are going to get sent to space, and not just people who are who are kind of at the pinnacle of health, but ordinary people, including people who might have pre-existing health conditions, or people who might not necessarily be in the best shape, or people from a variety of age groups, or and it'll be really interesting to see what space does to the body and just how much more we learn, not just about like, I mean, hopefully we don't learn this by like, anyone getting into an accident or they're exposed to this vacuum, but just in general about what space does to health. There's just so much left to discover. Like, I think in our lifetime, so much is going to be discovered on this front. Is going to be really cool to see.
Yeah, no, I'm sure there's going to be like a renaissance. It's like a whole new field. It's a niche field now, but it's going to be a whole new niche opening up. So.
Yeah, there's actually a lot of programs for it that are being created around the country.
Really?
That I've kind of heard about through the grapevine a little bit.
Yeah, I know you said that there's one at UCLA that's like combined with, what is it, Tesla? SpaceX, yeah.
Yeah.
That's really cool.
It's SpaceX. It's a space medicine fellowship. So that's really cool. The Mayo Clinic also has a fellowship. NASA has their own like residency program essentially for space medicine. So but it's also growing. Like I've heard that there are a few more programs, fellowships and stuff that are being created like in the next few years probably. So the field is growing really, really fast. Yeah. I don't know. I think it has a lot of potential. Yeah, there's also like I haven't even told you about all the cool things space does to the body with a spacesuit, because even if you're wearing a spacesuit, you're still not protected from space.
Really?
Yeah.
What happens?
Well, it's not like you're gonna face death anymore.
Yeah.
Which is a huge relief, of course. But you are still exposed to things like the radiation of space. And so yeah, the two main changes that you'll still experience even if you're wearing a spacesuit are the radiation and the lack of gravity. And those two things, like they both, so like the radiation, there's actually two kinds of radiation in space that we don't really get on Earth because we're protected mainly by the magnetic field around the Earth. But in space, if we go into space, we're kind of outside of Earth's shield. We sort of get hit by these sources of what are called, or I guess we call space radiation. And this can take on multiple forms. Like one form of space radiation is called galactic cosmic rays, which are believed to come from really distant supernovas or just really, really large stars that exploded essentially supernovas. And they kind of release these particles that are like moving out the ends of the from all directions. Those are galactic cosmic rays. And then there's also another form of space radiation that is emitted by the sun's surface. So sometimes the sun will sort of emit like a burst of these particles. And both of these sources are really high energy ionizing radiation forms. So they can pass through the spacesuit. They damage your DNA. They increase your risk of cancer, but they also increase your risk of any kind of degenerative disease. So like cataracts are one that's been very noted as a result of like all the radiation that you're exposed to in space. Because just the level of radiation and the fact you're constantly exposed to it. It's just the equivalent of so many chest X-rays.
Really?
I forget the exact number, but it's like,
so the spacesuit can't protect you against that. Like they can't put like kind of like protective like kind of things to deflect those rays, or no?
I think there are materials that are there to help mitigate it. They still receive a lot of radiation, and you can't really get away from it. At least not currently, to my knowledge. There might be something I don't know, but I believe that at least currently, a spacesuit cannot completely protect you from radiation. I think it doesn't protect you from the majority of it. But so there's that you're still exposed to in space, and then the lack of gravity is actually really, really, really interesting one because we're so used to living on Earth with gravity that I think sometimes we forget that our bodies are adapted under the assumption that we will always have gravity. So our physiology, our anatomy, we are designed for a place with gravity. So when we're thrown into a setting that doesn't have gravity, our body kind of goes a little bit haywire because we're not designed for that. Like our body's operating under the assumption we should always have gravity. So there are many things that happen in space without gravity. The first thing is your fluids, which normally by gravity are sort of pulled down towards your feet, they now distribute more evenly throughout your body. And what that means is that now your head has more fluid than it was used to, because normally some of that's being pulled down. But now your head has more fluid than it was really built to accommodate. So you start, there's actually it's kind of colloquially called the puffy face bird legs syndrome, or the puffy face bird legs appearance. And that's describing that in space, astronauts, their faces look a little puffy and their legs actually look thinner, usually thinner by about a third of the circumference approximately. So legs look thinner and their face look puffy, but that's just because a lot of fluid has just, like, there's just more fluid in their head and it's gotten pulled away from their feet and towards their head. So there's that difference in appearance. They can also feel like congested and stuff, but this actually creates like other problems as well. So like the longer that you're in space, particularly this is mainly seen once you've been in space for a month or so, is when you kind of start to see changes to the brain and to the eyes. So your brain kind of starts to essentially like swell up with fluid. Your ventricles expand. And so you get all this fluid in your head, and the fluid also swells the optic nerve as well. The optic nerve runs right above the optic chiasm, like right above the pituitary gland. So it pushes down on the pituitary gland and actually deforms. It compresses the pituitary gland against that cella turcica.
Oh my gosh!
And it just makes all that fluid. And then another thing is that because the optic nerve is swollen as well, the optic nerve attaches to the back of your eyes. So the swollen optic nerve and all this fluid in your head pushes against the back of your eyes. So it flattens the back of your eyes, and that actually leads to a far side vision shift. So like your vision gets blurrier, but in particular, you find it more difficult to see things up close. And that's just because basically just like your lens hasn't changed, but the light that's coming into your eye is now focusing behind your retina, so that's leading to farsightedness. I hope I'm not getting too technical.
No, I actually follow. Yeah, it makes sense because you're saying that the lens shape changes, right?
And so the lens actually doesn't change, but it's the back of the eye that flattens.
Oh, yeah. Well, wouldn't that change the lens? Like the retina? I mean the retina. Yeah, that's what I mean. Yeah.
So actually, like with the flattening of the back of the eye, like, you might also see like folds that will appear in like the retina or in the choroid of the eye. So like towards the back of the eye, you'll see little folds because it's gotten kind of swollen. So yeah, that can kind of mess with vision. And then there are other changes too. When you don't have gravity, your muscles and your bones don't have anything to work against. So a lot of times, like we don't even think about it. Even when we're standing up, we're using a lot of our muscles to work against gravity, just to maintain upright posture. And we have a lot of bones in our body that are like the main, or that are really serve the main purpose of being weight bearing bones, like just bearing the weight of our skeleton or the weight of our body. So those muscles and bones, the ones that keep us upright against gravity, the ones that we're using all the time without even thinking about it, those are the ones that will actually diminish the most in space. So you lose a lot of muscle mass and bone density in space, but you'll particularly see it in muscles like the erector spinae or like the quads, like the hamstrings and like those kind of muscles, like muscles of like other muscles of that up too. Like in the muscles of the calf as well. And then with the weight bearing bones of the body, these are the bones that will the biggest amount of like bone demineralization. Those are going to be things like your lumbar spine, your like pelvic girdle, your femur and your tibia, and like So those are some of the bones that will the biggest decrease in mass. But actually, even your heart, like the ventricles of your heart, will shrink as well because your heart doesn't need to pump against gravity. So it doesn't need to pump as hard. So you just get this muscle atrophy that's completely physiologic. Your body figures like, I don't need to work that hard. I don't need to maintain all this muscle. So it doesn't cause any problems in space. It's just once you come back to Earth, now you don't have the same amount of muscle mass and bone mass, and now you're subject to the same gravity that you were before you left.
Yeah, so you gotta probably rebuild a lot of them.
Another fun fact is that when you lose bone, it ends up releasing like health consequences that come out.
Certainly, it seems as though because with the gravity, I don't know if you've seen Interstellar, but I don't know if you remember that part where like time dilates and they're on a planet, and then like the guy's like the guy that's sitting on the spaceship is like 25 years older, but they were only on the planet for like an hour.
Actually, I have to watch the movie again. It's been so long since I've seen it.
So like, what about like how would time in like the time like dilation or time just kind of the effect of time interplay with some of these issues like the human body? Like, do we know anything about that? Like I don't know.
Yeah, no, that's actually a really, really, really good question because there's still a lot that we don't really know about the ultimate effect of things. So one that kind of comes to mind is one really surprising finding of NASA's twin study, which basically there were two identical twins. One of them stayed on Earth, and then the other one went up into space. And then the astronaut who went to space, his telomeres actually lengthened. So like normally the telomeres, because our DNA is linear, with each round of DNA replication, your DNA shortens a little bit. But we have these like end bits that are really not that important, so it's okay if they shorten. And the shortening of telomeres like kind of thought it was like a sign of aging almost. So like telomeres lengthening was a very surprising finding. Like being in space, like it's like whoa, it's not lengthened. It looks like it's like extending your lifeline. But then like there have been other kind of thoughts too that like your telomeres would also lengthen. For example, like in cancer cells that are kind of like that would also like be seen with that. So people were thinking, oh, maybe it's like the radiation that's causing that.
Oh, that's actually really interesting.
Which is actually a really interesting thought. It's really hard to like parse out the overall effect because space has a lot of detrimental effects on the body too. So yeah, it's really hard to say what good things could come out of it, especially if they're being masked by other bad things.
It sounds like you have like time dilation that's kind of working on you, but also you have like the radiation, which is kind of in the opposite direction, maybe.
There's just so much we don't know.
This has been super like interesting to hear. Like we've never known like especially the stuff with the spacesuit. I figured if you had a spacesuit, you'd be okay, but I guess not.
No, you just like you won't die though. So that's good.
Yeah, I guess that's
also
okay.
like if you stay in space, the things with like your muscles, bones, it doesn't really protect you from all of the radiation. Even the ship can't really protect you from all the radiation.
Oh man,
you kind of just
wow. People who go to space, that's really like there's a lot of helpers there.
Yeah. No, there's just so much. There's so many effects that space has on the body. There's also just I think there's just even more that we don't know than we do know. And I think so much is gonna kind of come to light in time too. But
So, if you could kind of changing lanes here. What would you say? Which chapter life are you in right now? If you name this chapter life, what would you say? What would be the name of it?
I'd probably call it. Maybe I'd call it the exploration phase. Just because I feel like I'm still sort of figuring things out a little bit. And I think right now I think I've just been so excited to learn more about this field that I feel like I'm kind of just exploring it along with everyone else. I feel like there's a lot that I don't know too. I just wish I could just spend all my time just reading more about this and about lots of things. But I feel like I don't know. I feel like I'm sort of at a point where I'm just excited to learn as much as I can. Be like maybe in the future I'd like to just do something with it too. But right now I think I'm gathering my knowledge still.
Yeah, no, I love that. That's really cool. That's like humble too. I love that. Yeah. Well, that's all my questions for you.
Thank you, Isaiah.
Yeah, thanks for coming on the show.
Thank you for having me.
Yeah, of course.
Thank you, Isaiah. I'm so honored that you had me here. So
Twitter, Instagram.
I actually don't really have much social media, but I am on LinkedIn. Or like anyone can email me as well. My email is
I think I can put in the show.
Okay, perfect. That sounds great.
Okay.
Thank you, Isaiah.
Yeah, of course.